Hello everyone. In this video, I am going to give a brief introduction to laser-produced plasmas. This video will be helpful to the beginners who are interested in the field of plasmas. Outline of the presentation is as follows. First, I shall give the brief introduction to the physical processes involved in laser ablation. Then I will tell you about single and colliding plasma plumes. After that, I shall discuss the various experimental techniques that are used to characterize the plasma, and future scope will be discussed at the end. Now let's see what is plasma. Plasma is a quasi-neutral gas of ions, electrons and neutrals which shows corrective behavior. It is also called as fourth state of matter. As we heat the solid, it becomes liquid. When we heat the liquid, it becomes gas. When we further heat the gas, it becomes ionized gas. And this ionized state is also called as plasma state. Now there will be a general question in everyone's mind is where do we find plasma? 99% of the universe is in plasma state. All the stars, including Sun, is in plasma state. Interstellar and intergalactic medium is also in plasma state. Occurrence of plasma on Earth is rare and limited to flash of lightning bolts and soft glow of aurora borealis. As we leave the Earth's surface, we encounter the plasma in ionosphere in the form of solar winds. We can also find the plasma in home as in the form of mercury lamp and sodium lamp. It has also been possible to produce the plasma in laboratory also. It can be produced either by electrical discharge or by laser ablation of solids. The fundamental process of laser ablation of solids can be divided into three regimes. First, laser target interaction, second, laser plasma interaction, and third one is plasma expansion. When a laser pulse hits the target, intensity of the target material causes evaporation of the target and primary plasma is formed. This primary plasma further interacts with the rest of the pulse and growth of the plasma takes place. Once the laser pulse terminates, the thermal energy of the plasma rapidly converts into the kinetic energy and plasma plume expands in the forward direction. Recently, the interaction of two colliding plasma plumes have gained much interest of scientific community because of its potential applications in pulse laser deposition, inertial confinement fusion, ion acceleration, and as laboratory models of astrophysical phenomena. When we focus a single laser pulse on the target, single plasma plume is formed. But when we focus two laser beams derived from a single beam on a flat target surface at two different spots separated by a small distance, then this results in two seed plasma plumes. These two seed plasma plumes evolve with time and interact with each other. Interaction between these two plumes may result in the formation of a stagnation layer. The nature of stagnation or interpretation depend upon the collisionity parameter. Laser-produced plasma is characterized by its physical parameters with electron temperature, electron density, velocity of expansion, and persistence of emissions. There are various experimental techniques by which we can calculate these parameters. For example, one can use optical emission spectroscopy to get an information about the plasma species in their excited state. It can also be used to calculate electron density and electron temperature of the plasma. One can also use 2D imaging technique to find out the velocity of expansion and lifetime of the plasma. In order to get the information about ion current density of the plasma, one can use retarding field analyzer or Faraday cup. One can also use interferometric techniques to find the information about refractive index and density of the plasma. Now I am going to show you the time evolution of single and colliding plasma plume. These videos of single plasma plume and colliding plasma plume give you a clear picture what is difference between single and colliding plasma plume. One can see here that due to the interaction of two seed plumes, a distinct stagnation layer forms which persists up to 800 nanoseconds, whereas single or seed plume persists only up to 300 nanoseconds. There are various possible applications of laser-produced plasma. Laser-produced plasmas nowadays are used as protective coatings. It can also be used to synthesize nanoparticles, and it has been also proven as an efficient nonlinear medium for high order harmonic generation, and laser-produced plasma are also being used as an ion source. The ion source is very effective in destroying the tumor tissues, and it is better than the proton beams. Laser-produced plasma are also used as a laboratory model of astrophysical phenomenon. Laser-produced plasma can also be used to deposit the multi-component film in a single run. Thank you so much for watching and listening this video.